Assalamualaikum, selamat sejahtera. Today I want to show you how to use or to apply the Henderson-Hasselbalch equation to solve the problem of buffer system. Okay, look at exercise number 1. Calculate the pH of solution containing 0.2 molar CH3COOH and 0.3 molar CH3COONA. First of all, the question asks you to calculate pH. From the previous lesson, we already learned how to calculate pH of weak acid and strong acid. For this solution, you have to recognize first, this solution contains only strong acid or weak acid or acidic buffer. So, look at the species exist in the mixture. This is your weak acid. Alright? This is organic acid, carboxylic acid. This is your salt. How should I know this is the salt? When you dissociate this, will become CH3, COO minus and H plus, and also dissociate this salt, CH3, COO minus and A plus. That means it will share the similar ion. If you check both these species have similar ion, automatically this is your salt. Okay, if you dissociate both these species and not have similar or common ion, that means this is not the salt. Okay, alright, so this is your buffer, because mixture salt and weak acid will become buffer solution. Okay, this is acidic. Why I said acidic? Because it added with weak acid. Okay, if you detect this solution is acidic buffer, that means you have to use Henderson-Hasselbalch equation. As we learned, you have two types Henderson-Hasselbalch equation, either pH or pOH. For this case, when you apply acidic buffer, you have to use pH equals to pKa plus log concentration salt over concentration weak acid. Okay, ataupun di sini you tulis conjugate base pun accepted. You have to use this formula because you tengah refer kepada acidic buffer. Alright, so di sini kalau you nak tulis formula, kita tak boleh tulis dalam keadaan yang general. Ini di dalam kita punya teori. Untuk menjawab soalan, you have to write in specific. Like this, pH equals to pKa plus log CH3COO minus over concentration CH3COOH. Kalau tak nak tulis yang ini, you tulis yang ni pun boleh, CH3COO and A. Either you want to write in terms of conjugate base or in terms of the salt. Okay, you just insert the value. Okay, for this case, this question asks you forgot to give you the value of Ka. Okay, so please add that the value of Ka is 1.8 exponent negative 5. Okay, the question must give you the value of Ka. Okay, so insert the value. P, that means negative log. Ka, just insert this value 1.8 exponent negative 5 plus log. What is the concentration for your salt? 0.3 concentration. Okay, your weak acid concentration is 0.2. 2, and you will settle down. You tekan calculator and you get the value of the acidic buffer is 4.92. Just enough 2 decimal places. This is your answer. For exercise 2, what would the pH of 0.2 molar CH3COOH if no salt will present? Okay, so the question asks you about pH. You want to use Henderson-Hasselbalch equation? For this case, no need. Okay, why I said like that? Okay, because CH3COOH solution, no salt. That means the mixture of this is weak acid plus no salt. So that means this is not buffer solution. So if you detect this solution, the mixture is not buffer solution, you no need to use Henderson-Hasselbalch equation. Okay, so what you want to do? Okay, if your solution only have weak acid, you have to memorize 7.1 for part 2 ice table. You have to use ice table. Why I must use ice table? Because this is weak acid. If you have strong acid, you use if table. Okay, so tengok balik nota macam mana kita nak guna ice table, and then KA diberi, kita perlu checking 5%. Okay, sama ada kita nak assume ataupun nak buat quadratic, and then you get lah the value of X, and X itulah the concentration of H plus, dan dapat concentration H plus, you will get the pH. The answer for this question is 2.72. You must try. You will get 2.72. We continue exercise 3. A buffer solution was prepared by dissolving 0.12 molar of ammonia and 0.095 molar ammonium chloride solutions. What is the pH of the buffer? Kb given ammonia is 1.8 exponent negative 5. For this case, you have no need to check either the solution is buffer or not, because it already stated for you this is a buffer solution. If the question did not state it, you have to check first either this is a buffer or not. Alright, because if you want to calculate pH of the buffer, you must use Henderson-Hasselbalch equation. Alright, okay. Now this buffer did not mention either acidic or basic. Can you guess? Yes. First, you can guess it's a basic buffer solution because it already give you the value of Kb. So confirm this a buffer, basic buffer. Okay. If you don't know, if you don't want to refer to this value, you also can just refer to the species. It involves ammonia. We already know ammonia is a weak base. This is your salt. Alright, salt mixed with the weak base, confirm this is basic buffer. Okay. If you want to use Henderson-Hasselbalch equation, which one? Either pH or pOH? Yes, since this is a basic buffer solution, you must use pOH equals to pKb plus log salt or conjugate acid over concentration weak base. But in the exam, you must write in the specific. pOH equals to pKb plus log NH4 Cl over NH3. Alright, or NH4 plus, also accepted, either one. Okay, so pOH equals to P is negative log, Kb is 1.8 exponent negative 5 plus log concentration ammonium chloride is already given 0.095. Ingat di sini adalah concentration. Kalau tak ada dalam concentration, you find first concentration and then baru you guna this formula. Okay, over concentration ammonia 0.12 and you settle down using calculator and you get 4.643. This is your final value. No, the question asks you about pH. You just find pOH. What you should do? As we know, pH plus pOH equals to 14. So if you want to get pH, that means 14 minus 4.643 and you get 9.36. This is your basic buffer solution, the pH.